Lesson 5, Simplifying Rational Variable Expressions. So we're going to review some factoring. So we're going to follow the two expressions that are given. In the first example, we have 6x squared plus 3x. Remember, when you are factoring, the first thing you want to look for is a common factor. And there is a common factor between these two terms, and that factor is 3x, and you'd be left with 2x plus 1. And now if you look inside the brackets, all we're left with is a binomial. And the only binomial that we know how to factor is a difference of squares. Since this is not a difference of squares, we can't factor this any further. Okay, second example. There is no common factor between the three terms. It's a trinomial. It's not a perfect square trinomial. It is a simple trinomial since the coefficient here is 1. So I need to find two numbers that multiply to negative 35 and add to 2. And those two numbers would be 7 and negative 5. So when I factor this simple trinomial, I get x plus 7 and x minus 5. Okay, rational variable expression. So since you're learning a new term, you should know what the definition of it is. So rational variable expression is a quotient where the numerator and denominator are polynomials. So basically what you're looking at is a polynomial in the numerator and a polynomial in the denominator of a fraction. Okay, so here's one example, 4 over x times x plus 2. And here's another example, 2x minus 10 over x squared plus 2x minus 35. So in this lesson, what we're going to see is how we can simplify rational variable expressions. Okay, so because we are going to have variables in the denominator of the rational variable expression, what's going to end up happening is certain values of the variable will give you an undefined result in the denominator. So, how can you determine which values of the variable will give you an undefined result? A value of the variable which makes any factor in the denominator equal to 0 gives an undefined result. This is because dividing by 0 is undefined. So here we have an example where we have 4 over x times x plus 2. And if we actually try to figure out what values of x would make either the first factor, which is x, or the second factor, which is x plus 2, if we try to determine what value of x would actually make those equal to 0, we would see that x equals 0 and x equals negative 2 are the two values of x. So think about what happens when you plug in x equal to 0 into the expression. What you end up with is 4 divided by 0 times 0 plus 2, or in other words, 4 divided by 0. Similarly, if you plug in x equal to negative 2, you have 4 over negative 2 multiplied by negative 2 plus 2. And again, this negative 2 plus 2 gives you 0. And so again, you have negative 2 times 0, which is 0 again. So in both of these cases, you'll notice that these specific values of x will give you an undefined result. So because there are values of x that will give you an undefined result, what this creates are some restrictions on the values of x that you can possibly have. And that's one of the things we're going to be looking at in this lesson. Here's another question. Will x equal 0 always be a restriction? Now, a lot of times students typically write x cannot equal 0 or x equals 0 as a restriction, but this is not always true. X equals 0 is only a restriction if there is a factor of x in the denominator of the expression. So here's one example, the one that we saw earlier. When you have 4 over x times x plus 2, what you'll notice is the two factors that you have are x and x plus 2. What this means is either x has to equal 0 in order for the denominator to be 0, or x equals negative 2 in order for the denominator to be equal to 0. So in this case, x equals 0 is a restriction. However, if you have an example like 1 over x minus 1 times x plus 2, your first factor is x minus 1 and your second factor is x plus 2, which means either x has to equal 1 or x has to equal negative 2. Notice that in this case, x equals 0 is not a restriction. Okay? And if we do plug in x equal to 0 in this expression, look at what happens. I plug in x equal to 0 here, x equal to 0 here, and you'll notice that your final value ends up being 1 over negative 2. That's not that does not have a denominator of 0, which means it doesn't give you an undefined result. So x equals 0 in this case is not a restriction. The only restrictions we have are 1 and negative 2. Okay, so we talked about this a little bit already. When we have variables in the denominator of an RVE, or a rational variable expression, this is just a short form, there are restrictions on those variables. Therefore, a rational variable expression is only defined when the denominator is not equal to 0. And the reason for that is because division by 0 is undefined. So just to remind you about the zero product property, if you have two or more terms being multiplied together and the result is 0, either the first term is equal to 0 or the second term is equal to 0, or both the first and second term are equal to 0. Okay, so if you have something like 1 over x plus 1 multiplied with x minus 2 multiplied with x plus 3, for example, here I have three terms in the denominator, and what that means is I need to solve each of these factors equal to 0 to figure out what value of x would make those factors equal to 0. And you should know how to do these fairly quickly. And so there's the three restrictions that we have. X equals negative 1, x equals 2, and x equals negative 3 are all values of x that would make the denominator here 0. Okay, so these would be our restrictions. And we'll take a look at the notation you would use to state your restrictions. Here's our first example. It asks us to state the restrictions on the variables. So when you are stating restrictions on the variables, the first thing you need is for the denominator to be equal to 0. For the denominator to be in factored form. So if the denominator is in factored form, you should be able to state the restrictions right away. If the denominator is not in factored form, then you need to write it in factored form so that you can determine the values of x that will make the denominator equal to 0 or the expression undefined. So let's take a look at the first example. And remember that the restrictions only exist on the variables that make the denominator equal to 0. The numerator can be equal to 0. You can have 0 divided by any number. However, you can't have any number divided by 0. Okay? So here's our first example. We have 4 factors. And the first factor is just a numerical part. So here the numerical coefficient will never give me a result of 0. Okay, so the only values here, or the only variables here that can give me a result of 0 are the x, the y, and the z. And the only way x can make the denominator equal to 0 is if x is equal to 0. So one of the restrictions I have is that x cannot equal 0. Okay, that's a value of x that I can't have for this expression. Otherwise, I'll get a denominator of 0, which would be an undefined result. Similarly, the only value of y that will ever make the denominator equal to 0 is that y cannot equal 0. Okay, so y equal to 0 is another restriction, which means I cannot have y equal to 0. Same thing with the z. The only way to make the denominator equal to 0 is if z is equal to 0, so that's another restriction. So basically, what I have here, and here's another way of writing the exact same thing, is that x, y, and z cannot equal 0. Okay, for the next example, similar idea. And so again, I'm just looking at the denominator and trying to figure out what values of the variable will make the denominator equal to 0. I don't care about what's going on with the numerator, and my focus is only on the denominator. So here I have 1, 2, 3 different factors. Those are the 3 things that are being multiplied together in the denominator. So similar to what we had up here, the coefficient of 5 will never give you a result of 0. However, the value of a here, if it's equal to 0, will give me a denominator of 0. So one of the restrictions I have is that a cannot equal 0. Okay? The other factor that I have here has a plus 4, which means that if a is equal to negative 4, this bracket here will be equal to 0, which will make the entire denominator equal to 0. So my second restriction is that a cannot equal negative 4. Okay? Ideally, you want to write this in a much easier to understand kind of notation. So instead of having to list the value of a each time, the other way you can write this is that a cannot equal negative 4, comma 0. So this says a cannot equal either one of these numbers, and ideally you want to list the numbers from lowest to highest. Okay, here's our last example. What you'll notice in this example is that the denominator is not in factored form. You need to get it in factored form first in order to be able to see which factors you have and how each of those factors can be equal to 0 in order to figure out the restrictions. So the first thing I'm going to do is I'm going to factor out the denominator, and I'm not worried about the numerator. I'm not trying to simplify in this case. I just want to know what my restrictions are. So hopefully you remember this from the review on the first slide. If we factor this, the common factor is 3x, which means I'm left with 2x plus 1. And again, now I have 1, 2, 3 different factors in this case. 3 will never give me a result of 0. However, x cannot equal 0 since it'll make the denominator equal to 0. And finally, for this set of brackets, x cannot equal negative a half. Because then if this set of brackets is equal to 0, then the entire denominator will be equal to 0 as well. And I'll show you in a second how I got x cannot equal negative a half as well. Now again, nicer notation, I should be writing this as x cannot equal negative a half, comma 0, lowest to highest. Now in case you're wondering how I got negative a half, I'll just show you that on the side. So basically what I'm looking at is what value of x I cannot have. So I know I can't have x equal to 0. We established that. But now when I have 2x plus 1, I can't have this equal to 0. Because if it equals 0, I get an undefined result. So basically what you're going to do here is try to isolate the x. So if I move the 1 over to the other side, I get 2x cannot equal negative 1. And now to isolate x, I need to divide both sides by 2. And I get x cannot equal negative 1/2. So in case you're wondering how I got that fractional answer, I just isolated the x in that set of brackets.